Hi guys, this is the Unit 6 review guide. First I want to just give you an overview of what we've done so far. So we've been solving 1 and 2 step problems, except we've been using inequalities. So the thing you need to know is if you have x is less than or x is less than or equal to, it's going to create a certain type of graph. You have your xy plane, sorry, for that one. If you have x is greater than or x is greater than or equal to some number, your xy plane is going to look different. So I'm going to make up some numbers. So we have 1, let's say we have 1 here. Let's say we have, -2 over here, right? So if it's greater than, then it's just a vertical line, and it's going through 1. It's a dashed line going through 1. For less than, we're going to be to the left of that dashed line. Now, if it was equal to, we would instead make that dashed line a solid, right? Now, for greater than, let's go find -2. It's just a vertical line, and it's dashed, right? And if the values are greater than, it's going to be to the right, shade to the right, greater than. However, for equal to, it's a solid line going through -2. So less than is shade to the left, shade left, shade left. Greater than, shade right. And it's only for x is for those x or x only. Okay? But when we're talking about y, so y is less than something, or y is less than or equal to. And then we have for y is greater than, or y is greater than. First of all, we have dashed lines for these two. And we have solid lines for these two. Now graphically, what does that look like? Well, if I have this line, let's say I have this line. That's my line y, right? If it's less than, then I always shade below this line. I shade below the line. Shading below the line. Now, it's equal to, so when it's equal to, I make a line solid, right? On the other hand, if it's greater than, let's go find the line. There's a line, right? If it's greater than, I shade above the line. Shade above the line. If it's equal to, I make the line solid. That's basically an overview of what this looks like. Now, moving on to the actual review. Now, number 1, if I'm solving this, I'm going to rewrite it. Now, keep in mind, if you multiply or divide by a negative number, the symbol flips. So one thing we want to keep in mind. So let's go ahead and do this first problem. Just rewriting it. So the first thing I'm going to do, I'm isolating the y term, the variable, solving for a variable. So that means I'm going to add 3 to both sides. Get -4y. This goes away. Symbol comes down. Equals or greater than or equal to 20. Now I'm dividing by -4. When I do that, my symbol flips over. And this cancels. Y is less than or equal to -6. Here's my final answer. Okay, number 2, I have 10 less than 3/2 times x plus 4. Now I'm going to subtract 4 on both sides to isolate that variable term. I get 6 is less than 3 halves of x. This goes away. I want to get rid of the fraction. I'm going to get rid of the fraction, so I'm going to multiply the reciprocal, 2/3, both sides. And I get 4 is less than x, and these cancel. Alright? Moving on to below, we have 7y plus 2. 7y plus 2. I'm going to put a 1 from that y, minus 15. Subtract 2 on both sides. You get 7y coming down. This goes away. Symbol comes down. 1y comes down. Minus negative 17. That, I want to get my y terms on the side. So I'm going to subtract 1y on both sides. I get 6y is greater than negative 17. Divide both sides by 6. And y is greater than negative 17 over 6. Okay? Next one, I have 12x's minus distributing this negative 5. I get 10. I get 10. And then distributing negative 5 to negative 3x, I get plus 15x less than 2. Combine my like terms here, and I get 17x's minus 10 less than 2. Add 10 to both sides. I get 17x's. This goes away. Symbol comes down. 12. Divide both sides by 17. And x is less than 12 over 17. So for my answer. Okay. Moving on to page 2. Now we're talking about going to choose these properties, choose from these properties to describe what is happening in each step. So the first step is given. The second step, I'm going to go through and highlight what changes. So nothing changes on the right side, but these two things, they slide the parentheses, they slide these parentheses. This is what changes. When they slide parentheses, when they add two other things other than what they started out with, we're doing the associative property. This is the associative property of addition. Now, next step, what did they change? Well, it looks like they changed the order of these two terms here. So that's the commutative property. We switched something over. We switched two things. It's commutative and it's multiplication. The next one, they distributed. They distributed that negative 2. So that's the distributive property. Next two, they combine the like terms. They combine 1 and 3. Then they added x to both sides, so that's the addition property that we call it. Next, they did the subtraction property because they subtracted 2 from both sides. And then lastly, they divided, so it's division property. So basically, properties describe the action that you're taking as you move forward to solve for variables. Now, you're going to write an inequality and then solve to find the minimum number of candy boxes. So Samara has already earned, she has $200 and is selling candy at $5 per box. So 5 per box. 5B. She wants to raise at least, remember for at least, it's going to be a greater than equal to. So she already has $200. She's selling at 5B. So we're just going to subtract 200 on both sides. We get 5B is greater than or equal to 300. Divide both sides by 5. B is greater than or equal to 60 boxes. And that's my final answer. Number 7 is graph the inequality. Now, it's in y is by itself, so m is equal to 4. Negative fraction for 1. B is equal to negative 3. I'm shading as a dashed line, and I shade above the line. Okay? So first I'm going to go find B on my graph. Here's B, it's at negative 3. Then I'm going to go up 4, right 1. So up 4, right 1, up 4, right 1. And there's my line. It's a dashed line, so and I shade above this line, so I highlight above the line. For number 8, y is not by itself, so I'm going to do y by itself. That means move my x term over. Again, this goes away. Negative 4y greater than or equal to 16 minus 3x. Divide both sides by negative 4. When I do, the symbol flips. I get y is greater than or equal to negative 4 plus 3 over 4x. My slope is 3 over 4. My y-intercept is negative 4. I'm shading up, and it's a solid line. Okay? So I start at negative 4, and then I go up 3, right 4. So up 3, right 4. Up 3, can't go any further. So create my solid line here. And I shade above the line because it's greater than. We started off with less than, but because we divided by a number, the symbol flips. Divided by a negative 4, and the symbol flips. Alright? Now we're going to write an inequality. That means we need to find our y-intercept. And it's right here. It's at negative 2. B is negative 2. This is below, so it's y is less than. So I'm just going to do a little star here for right now. So things I know right now. I know that y is less than because it's dashed line, and it's below the line. It's not equal to. My y-intercept is negative 2. I just need x. I need the slope, so I'm going to pick another good point. Here's another good point, and I go 1, 2, 3. 1, 2, 3. So down 3, and right 1, 2, 3, 4. So negative 3/4 x. This is my inequality. This is my linear equation. Number 10, same type of thing. I need m, I need b, so I'm going to go y star mx plus b. The star just describes the inequality. So the inequality is equal to, because it's a line of solid, it's above the line, so it's greater than, y is greater than. Now for my y-intercept, it's at 3, so plus 3. My slope, pick another good point. Here's 1, I go 1, 2, 3, 4, down 4, 1, 2, over 2. So my slope equals negative 4 over 2, or just negative 2. My equation is y is greater than or equal to negative 2x plus 3. Moving on. For the next one, it says let's go back to the previous page. See what's at the bottom here. So it says 11 and 12 um, 12, I'm going to do 12 to first. 3x minus 2y is less than 6. So 3x minus 2y less than 6. Alright? And then the other part is just a graph. So I'm going to graph these points. To graph the points, if they fall inside of the shaded area, then they are part of the solution. So I'm going to get that graph really quickly. Hold on. Okay, guys, so I'm sorry about that confusion. I have to go and copy this graph. So for this one, we're going to graph the points to see if these points fall into the shade area. They cannot fall onto the line because the line itself, the dashed line, is not a solution. So 0, 4, and then it goes just stay, and go up 4, and make points. So stay, go up 4, and make points. This is not on the curve, so I can exit out. For -1, -5, I go left 1, I go left 1, down 5, so left 1, down 5 units. And it's exactly on the line, so this is not a part of that solution set. For the next one, I go right 3, down 2, so right 3, down 2. It is in the solution set, so I circle it. It's in the shaded area. That's how you solve this problem. You do this one, -2, -3, and the point 1, 3. But for the next one, I'm going to rewrite the equation, the inequality from the previous page. So I'm just going to go look at it really quickly. And I have 3x minus 2y is less than 3x minus 2y is less than -6. So I'm just going to work on that. And I'm using these coordinates. So I'm going to try to get another piece of paper. So I have 3x minus 2y is less than -6. So the way I check this, I'm going to label each point. I'm going to see if the inequality works out. So what do I mean by that? So the first point, -2, 5, I'm going to substitute this in. It's 3 times -2 minus 2 times 5. Is this less than -6? That's the question. So I get -6 minus 10 less than -6, and -16 less than -6. This is true, so I can circle this answer. Now I want to check the next one. So I'm using the same formula, 3x minus 2y less than -6. Is this statement true when I'm using the coordinates 0, 0? So 3 times 0 minus 2 times 0 less than question mark -6. Is this statement true? 0 less than -6. This is false. This is false. So this is not true. Checking the next one is 2, 10. 2, 10. When I plug those in, is that less than -6? Well, 3 times 2 minus 2 times 10 less than -6. That's going to give me -4. It's -4 less than -6. No, it's false. So I X that out. And then I check the rest. 5, -2. So I say 3 times 5 minus 2 times -2. Is this less than -6? I get 11 less than -6. This is false. So I X that out. Is what about -2, 0? So it's 3 times -2 minus 2 times 0 less than -6. Less than -6. -6 is not ever less than -6, so this is false. The last one is 0, 1, so 3 times 0 minus 2 times 1 less than -6. This is true. I get -2 less than -6. This is false. So I X it out. So there was only one solution for that particular problem. Alright, so it says evaluate the expression. So I have when x equals 125 and y equals -8. So 2 cube root of 125 plus -8 squared. I get 2 times 5 plus 64, or 10 plus 64 equals 74. So A is my answer. 15. What are the x and y intercepts of 6x minus 3y equals 24? So remember, to find the x intercept, let y equal 0. So I have 6x equals 24. This is my x intercept. And y equals 0. Right? So I divide by 6. X equals 4. My intercept is 4, 0. The x-intercept is 4, 0. Now for my y-intercept, let x equals 0, so x equals 0. And I have -3y, the y term equals that number. Divide both sides by -3, and y equals -8. So my coordinates are 0 and -8. And these are my answers. These are my answers. X-intercepts on the top in the black, y-intercepts on the bottom in the red. And that's pretty much it for your review. Have a great holiday. Thank you for bearing with me. I'm sorry I've been sick, really sick, and I hope everything goes well over the holidays and you enjoy your vacation.